Okay, in today's lesson, we're going to continue on with unit conversions, and today we're going to look at odd unit conversions. These ones are the most entertaining, and based on the two examples we're going to do, you might think that they're not particularly useful, but they're very good at doing two things. One of those is making sure you understand how the method works without being able to logic your way through it, because there is no logic to them. They don't make any sense. The other thing is they actually are useful in real life for things where we can equate things, but they're not actually directly unit conversions. So you'll see one of these examples in the homework where if I want to know how much it's going to cost for me to take, for instance, a trip to Toronto in my car, despite the fact that distances and money are not equivalent to each other, because I have things like I know how far it is and I know what mileage my car gets, how many liters it takes to go 100 kilometers, and because I know how much the price of gas is per liter, I can actually do this unit conversion method to convert the distance I'm going to drive into a financial amount of how much it's going to cost me. So even though those aren't real unit conversions, this method will solve those problems, which is kind of cool. Okay, let's start off with one that is completely nonsensical. And I don't know how many of you have seen the old Batman television show. It was super cheesy. And every time Batman or Robin punched somebody, it made sound effects on the screen. So I've kind of tried to show you that in that little picture there. And for our question, we've got that Batman made all these sound effects when striking villains. So he's going to use his Bat computer to analyze the sound's relative strengths and figure out how many poofs it takes to add up to a single zowie. So if he punches a criminal and gets a zowie, how many times would he have to punch him with a poof to get the same result? So below that, we have a whole bunch of equivalences. We have that one pow is 3.89 blams, one crunch equals 11.5 poofs, a thwack equals 5.36 blams, a zowie equals 1.69 pows, a crunch equals 4.79 swooshes, and a thwack equals 10.5 swooshes. Now, does that make any sense whatsoever? And could you logic your way through this? I think you'd struggle a fair bit and have a hard time. But if we actually use our method, I think we can get there pretty easy. So what we're doing is we're going to start off with a zowie. And unfortunately, I'm going to not use the first letter necessarily because there's a few of them that have the same first letters. But I'll try to put some little little shortcuts there. So what we have to do is convert zowie into something. And remember, we're starting with a zowie, a single zowie, and we're trying to find how many poofs. So if I had number of poofs in a zowie, this would be easy, but unfortunately I don't. So what I have to do is look through my list and see if I can find a zowie there. And I see it right here. I see that a zowie is equivalent to pows. So if I go from zowies to pows, and then over here in this one, I can get from pows to blams. And then I keep looking around and say, oh, here it is. Blams and thwacks. Those are equivalent. Or at least I know the equivalency between them. Thwacks and swooshes. And then swooshes and crunches. And crunches and poofs. Perfectly. We've closed the circle. So this is how we convert zowies into poofs along that relatively long, drawn-out process. But the good news is that despite the fact that it's a long chain, doesn't change the fact that the method is exactly the same. So I'm going to do one zowie, and then we have 1, 2, 3, 4, 5, 6 fractions. And the units on the top are just going to be the things in the chain in the same order. So we already have zowies, so we'll go pow, blam, thwack, zwoosh, crunch, and poof. And I'm not going to be too concerned about the abbreviations I'm using there as long as it's clear what they're supposed to be. And then the next row, in the bottoms of the fractions, I'm going to do the exact same things in order, but leave off the poofs. So zowies, pows, blams, thwacks, zwoosh, and crunch. And now I look back at those equivalences above and I say zowies to pows. That was 1 zowie is 1.69 pows. The next one I'm looking for pows and blams. That's the first one on my list. So 1 pow equals 3.89 blams. Thwacks and blams. That's the third one. So 1 thwack is 5.36 blams. Swooshes and thwacks. That would be the last one. 1 thwack is 10.5 swooshes. Crunches and zowies. Crunches and swooshes. We have 1 crunch is 4.79 zwoosh. And poofs and crunches, 11.5 poofs equals 1 crunch. Okay, so now if we were trying to logic our way through this manually, we're likely going to mess up something somewhere. But the units tell us where to write all the numbers. Now we just have to make sure that we put them in the right place. And I realize we're running out of a little bit of room here, but that's okay. We should go through and check units. Zowies cancel, pows cancel, blams cancel, thwacks, swooshes, crunches, and the only unit I see left is poofs, which is perfect because that's what I want my answer to be in. And now I'm just going to go across the top and say we've got 1 times 1.69 times 3.89 times 1 times 10.5 times 1 times 11.5. And that gives me 793.8 poofs. And at the bottom, 1 times 5.36 times 1 times 4.79 times 1 is 25.67. And finally, I'm just going to take the top 793.8 divided by the bottom 25.67, and I'm left with 30.9 approximately poofs. So that tells me that 1 zowie is 30.9 times as powerful as a poof. Again, could you have done this one logically? I think I would have gotten lost and confused, but if we use the method, even though it may take us a little wee bit of time, the actual answer is pretty easy to get. Make sure that we set up our chain correctly, put our units in the right places on those fractions, and then put the numbers beside the appropriate units. That's it. Let's try one more of these to make sure that we can do it. This one at least is a little bit more realistic. Not by much, but by a little bit. And we're going to take a look at the Redneck Farmer's Almanac, which uses the following animals as equivalences. So for instance, if one farmer went up to another and said, I want to trade one of my sheep for your chickens, how many chickens should you give me? This would tell them, okay, 60 chickens is equivalent to 1 sheep, or 10 pigs is equivalent to a horse, or a cow should be equal to 30 roosters, or so on. Now, I'll be honest, I'm not a farmer, so I don't know if this is correct. In fact, I highly doubt it's correct, but it's what we're going to use for this problem. So what we want to find in part A is the number of roosters that a goat is worth. Now, I find students often get the wrong order on these, so we have to think about which is the thing we know and which is the thing we want. So even though it doesn't necessarily say it in numbers, we know we have a goat, and we want to find the number of roosters. So we want to get from goat to rooster. Now, if we had an equivalency there between I don't know why rooster looks so funny. If we had an equivalent between goats and roosters, that would be fantastic, but I don't think we do. So what we're going to have to do is go from goat to something. So I look down my list for the word goat, and I notice it's actually at the bottom one, and it's equivalent to 4 pigs. And when I'm making the unit chain, I don't even care what the numbers are yet. I just care that there's an equivalence between goats and pigs. And then I look back through that list, and on the second one down, I see that there's an equivalent between pigs and horses. And while I'm doing this, I don't know that I'm going to end at rooster, but I hope I can find a rooster eventually. So now we're going to go from horses to roosters. And then the third one down, I can go from roosters to cows. And, oh, wait a second. Why am I continuing? I've already gotten to rooster. So let's go back. I didn't need to go any further. I could stop once I hit rooster. I was getting ahead of myself there. Okay, so now we start off with one goat. And in this particular case, I guess they're all different letters to start, so I think we're okay to just use the first letter abbreviations. From goat, we go to pig, horse, rooster, so there's going to be 3 fractions. So goat, pig, horse, rooster. And on the bottom, goat, pig, horse. So now I have to look up at my exact equivalences between pigs and goats. And the last thing says that 1 goat is equivalent to 4 pigs. And then 10 pigs is equivalent to 1 horse. And 1 horse is equal to 40 roosters. So now goats cancel, pigs cancel, horses cancel. And I'm left with on the top 1 times 4 times 1 times 40, which is 160 roosters. And on the bottom, 1 times 10 times 1 is 10. So 160 divided by 10 is 16 roosters. Now, I don't know if that makes real sense in real life, but that's according to the list we were given, 1 goat is equal to 16 roosters. So that would be considered a fair trade. Okay, for the second one, part B, we want to find the number of chickens a cow is worth. So we know we start with a cow. We want to find the number of chickens. So we want cow to chicken. So writing out our list, we're going to start with cow. Looking at my list, I can go from cow to rooster. I can go from rooster to horse. I can go from horse to pig. I can go from pigs to goats. I can go from goats to sheep. And I can go from sheep to chickens. Okay, so that's a relatively long chain, but either way, it got us from cows to chickens, which is what we wanted. So now we just set this up. 1 cow. And from there, we're going to have 1, 2, 3, 4, 5, 6 fractions. And again, I think we can probably, for the most part, just use first letters. I think cow and chicken are the only 2 that both start with C. So we'll just write those out a little longer. So across the top, we should have cow, rooster, horse, pig, goat, sheep, chicken. And across the bottom, same thing, just shift it over 1. Cow, rooster, horse, pig, goat, sheep. No chickens on the bottom because I don't want chickens to cancel out. So now I just read off my list and see the relationship between roosters and cows is 30 roosters per cow. Horse and roosters, 1 horse is 40 roosters. So notice I don't have to think about whether I multiply or divide by the 30 or the 40 at any point. The numbers tell me where they have to go. The equivalent fractions tell me where they have to go. Pigs and horses. 10 pigs is a horse. 1 goat is 4 pigs. Sheep and goats. Where is that on the list? 4 sheep is 3 goats. So there's an example where the top and the bottom are both not equal to 1. Happens from time to time. And then finally we have a sheep and 30 chickens are the same. Okay, running short on room, but enough that we can finish the question. If we cancel out everything that we can, cow, rooster, horse, pig, goat, sheep, on the top we're left with 30 times 10 times 4 times 30. And that gives us 36,000 chickens. I should include the units that are left, and chickens was left on the top. And on the bottom, I have 1 times 40 times 1 times 4 times 3. So that gives me 4 times 1 at the end, but it didn't do anything, divided by 480. And so I just do the 36,000 divided by 480 gives me 75 chickens. So now I know that a fair trade would be 1 cow in exchange for 75 chickens. Again, this one is at least semi-realistic. I mean, there are situations where this kind of bartering may be used, and being able to calculate equivalencies for fair trades is a good idea. But like I said, there's all kinds of interesting ones where they seem to be nonsensical. It's not as simple as feet and meters and kilograms and pounds, but the unit conversion method is identical. So I'm going to get you to try a couple of questions here. We have one that deals with apples and bananas and other fruits and their equivalencies, very similar to the one we just did with animals. And then I'm going to get you to do one where you're going to convert Guitar Hero songs into dollars, which is actually a semi-real ability. We're going to do that one that I was mentioning at the beginning of the video about figuring out how much a trip would cost for me to drive somewhere based on a whole bunch of factors, but you can treat it like unit conversion. And then you're going to do one, it's not technically nonsensical, these are real units, but you're going to figure out the speed of a snail who moves along at 16 furlongs per fortnight. And furlongs and fortnights are both units that you can equate to things that you do know. And then you're going to treat that one as kind of a nonsensical one, but it's also one with a multi-unit. So stuff from yesterday and stuff from today, and really stuff from the day before as well. Give those a shot. Let me know if I can help you out in any way. Otherwise, I will see you later.